In this lab, we're going to build a power supply using an AC source. So we're going to create a DC source from an AC source. We're going to use this plug-in transformer that uses an input voltage, 120 volts AC, 60 hertz. We're going to plug that in, and initially we're going to take a look at the output. So that's what we're first going to do. So I'm plugging my transformer into the outlet here. Now I'll take a look using my oscilloscope at what our output looks like. Okay, so on the oscilloscope, we see we've got an AC sine wave signal with a peak-to-peak voltage around almost 50 volts, an RMS voltage of 17.7 volts, and a frequency about 60 hertz. Now I'm going to check out the amplitude and the offset using my digital multimeter. So I've got my digital multimeter here set up to DC volts, and we'll connect that to this input and just see what it reads. So I have about 0 volts DC offset. If I look at my AC offset, it's about 17.6 volts, which is what I just saw for my AC voltage using the oscilloscope. Now I'm ready to rectify this voltage to create a DC source. So I've got this circuit set up where I've run that other side of the transformer into the 4-diode rectifier. And then my output will be displayed off this 1 kilo ohm resistor. This should rectify the output so it looks like double the frequency and a bunch of humps above 0. So connecting my oscilloscope output to across this 1 kilo ohm resistor, we see on our oscilloscope here, this is what our rectified output voltage looks like. Notice we got an RMS voltage around 16.7 volts, a peak-to-peak voltage of 24 volts, so it's like half of the 50, and a frequency now almost double, 120 hertz instead of 60 hertz. Now this doesn't look very direct current. It looks like it's oscillating. So in order to smooth that out, we can add a capacitor across the output voltage. So I'm going to add this capacitance across that 1 k ohm resistor. Okay, and I'm going to set my capacitance initially to 100 picofarads. And let's just look at the output and see what happens. So here's no capacitance, here's a picofarad, 100 picofarads, not much. If we move up to say 1/10 of a microfarad, still we don't see much variation. Here's 1/10 of a microfarad, here's 1 microfarad. Now here you start seeing the bottom part raise up. And as I increase my capacitance, notice I start approaching more and more like a DC voltage. This is called our ripple here. And the higher the capacitance, the smaller the ripple.